Hi everyone, my name is Jonathan, and in this video, I'm going to be discussing building C++ projects. So we're going to demonstrate building C++ projects using just like command line and also using CMake and why we might want to use CMake as like a build system. So yeah, as a prerequisite, I'm going to kind of assume you have a basic C++ knowledge. And if you want to follow along, you need like a compiler along with CMake installed with it. So right here, you can see like a really basic C++ project structure, which is going to contain the bin for our executable, build for CMake to do its thing with intermediate files, include for all the headers to live in one kind of spot, a lib subdirectory, and some people call this external, but this is essentially where our source directories or static library files for external libraries are going to live, and the source subdirectory, which is going to contain like all of our own code. So yeah, let's kind of go over first building with the command line. So yeah, to build with the command line, depending on whatever compiler you're using, I'm using GCC. You're just going to follow like the commands for that. So first, you might want to compile like any libraries, which is going to be done with the -c flag. And then you want to compile and link against those target libraries with -o. And finally, you have a built executable, which you can run. So let's like demonstrate that really quick. So yeah, here I have like I've created a project with exactly the structure that we mentioned before with a bin, build, include. So we can kind of discuss what this is before and the lib folders. So yeah, here we have a really basic hello world program. And to build this, well, what we actually want to do is we can just build with by including the name of the file, and we want to kind of output. So I kind of discussed how we're trying to build into like the bin directory. So let's do that. So let's build into this bin subdirectory, and let's call this demo.exe. So you can see that we've compiled, and in bin, we now have demo.exe. So let's like try to run that bin demo.exe, and we get hello world. Okay, that's great. So yeah, and oh, just to kind of mention, like I do not have a source subdirectory here. I'm just going to kind of do everything within the root directory for like our source files, just to make things a little bit easier because we don't have particularly many source files. So yeah, just wanted to mention that. Yeah, now let's like try to use this like wrapper class around an integer. So this is like a really basic class that I'm just going to be using to kind of demonstrate how we can include maybe another header with an implementation of it. So yeah, to do that, we want to include it in the first place, right? So include, and we're going to try to include myClass.h, and we want to use it, right? So you can already see VS Code is complaining because there's something wrong. I will kind of go over why that is. myClass.8. So let's instantiate it with a value of 8. So yeah, let's try to build this. You can see there's actually no such file or directory. So this is because we've put our header file within the include folder. And actually, the compiler cannot see this file. So if we like kind of drag it to the outside here, and now we try to build, we get a different error. And we can talk about that later. But essentially, if we want to organize everything into this include subdirectory, we have to tell the compiler to look in this subdirectory for header files. So to do that, we use a -i flag, and we specify the include subdirectory to look for header files. Okay, so now we get the same message as before with undefined references. Well, if you guys know about linking, well, what the compiler will do is it actually kind of sees this header file, which provides like this kind of interface for the myClass, but there's no implementation of these member functions. So we have to actually link against some other like source file to have an implementation for these functions. So let's go ahead and do that. We're just going to add myClass.c++. Okay, great. And now let's run bin demo.exe, and we get the same thing. And let's actually just try to print out standard cout a.get the value. So just to demonstrate that we are actually doing something here with compiling a new program. Okay, cool. So now we get the value of a and hello world. Okay, so now let's kind of dive into maybe a more complex case of compiling. So now let's try to compile a program where we actually spawn like an external window. So to do that in C++, we're going to be using the OpenGL external library. So this is just for demonstration purposes, but yeah, let's actually have some boilerplate source code to spawn us a window. So here we go. Here it is. And yeah, so the header files for all the implementations of this is actually in GLFW. So yeah, here let's include that. So hashtag include, and we're going to include GLFW, GLFW3.h. So now you can see that we've resolved all these like kind of names, and we can see all these names. So let's try to build it. Okay, you see a lot of problems because once again, we haven't specified anything for the compiler to link these functions against. So it's the same kind of errors, undefined reference as before. So yeah, we have to specify a location for the implementation of these functions. So to do that, well, we actually have that in the external, in the lib folder, right? So we've provided, well, I've taken this kind of from the GLFW website, and these are the proper library files for static library files for MinGW. So if you're on Linux or a different platform, of course, you would want to have the appropriate like kind of files for that, and you can find that on the GLFW website. But here I kind of have it already installed and downloaded, and we're going to just link against that. So to link against that, what we're actually going to do is we're just going to specify this external library to link against. So yeah, here we go. Just to make sure that I'm doing this right, I think, yeah, we're just linking against, sorry, lib/glfw/ and we're going to be using a static. So it's the one that I've highlighted here, the one that ends with .a. So we're going to statically link, so lib/glfw3.a. So yeah, here we go. This should work. Oh yeah, sorry. So this is actually a great demonstration. So you see that the message has changed quite a bit. So what's happening is GLFW is just an interface between your computer's implementation of all these functions and like into a more kind of centralized location. So we actually have to provide more external libraries for our compiler to link against. And these external libraries are actually, so this is all documented on the website, which is why I'm kind of like looking over here. I'm actually taking a peek at what I'm supposed to be linking against. And we need to link against GDI32 and OpenGL32. So let's try that. Now you can see that we've actually built something. Let's try to run demo.exe. Oh, sorry, bin demo.exe. Cool. And you guys can't see it, but once I drag it here, we spawn this world, or not this world, but this window with hello world, right? And that's great. So yeah, we've actually built a program with an external library. So now let's actually try to do something with OpenGL. So let's change the background color of this window. So that code is right here. And what we actually want to do is use GLEW, which is just kind of an interface between OpenGL bindings and yeah, so let's just try to link against that. So you can see we have like this GLEW folder right here. This is actually the source folder for GLEW. And how you use this is first you want to build this on whatever setup you are. So this is all on the website, but essentially once you build it, you should receive these libraries, static library files as before. So yeah, let's kind of include that. So hashtag include. And if I'm not mistaken, it should be GL/. So like the header file is always provided separately, and then glue.h. Cool. And just as a disclaimer, if you're actually interested in graphics programming, we want to include GLEW before GLFW. Just like that's just how it works. Yeah, so that's great. And yeah, I've uncommented this code, and you can see that we've resolved GLEW init now because it's contained within this header file. And now, of course, if we try to link again, we're not actually linking against a library, so undefined reference to implementation of GLEW init. So we have to provide it with an implementation, right? So let's actually provide it with implementation with this lib. So yeah, once again, we're going to kind of have to specify lib/glue/lib lib slash glue32.a. Okay, cool. And oh, no, so I forgot a period here. Cool. So yeah, once again, we receive undefined reference. And the reason for that actually is because we need to link with more external more external libraries. So this is like kind of all documented on like GLEW and GLFW's websites. So yeah, it's gonna look kind of like magic for now, but just know that we're linking against kernel 32 and user 32. So, oh, undefined reference. So, okay. Quick cut and a little bit of debugging later. I actually forgot to include this define. So define glue static. Yeah, so since we're compiling against the static library of glue, so anything that ends with .a is a static compiled library, and anything that ends with DLL is a dynamic library. So yeah, we need to actually include this define. You can also provide this in your compilation message with glue static. So yeah, I think I'm going to include it in the compilation message just to make this a little bit more convoluted. And you can see we've actually successfully yeah, compiled. So I'm just going to clear the command line. So once again, this is the command for compiling this program. And yeah, let's try to run it. Then see, and you can see that now we have a white window. Ooh, very cool. So yeah, if you want to go into graphics programming, of course, you can do more work with this. But yeah, for the sake of our demonstration, yeah, I think this is as far as we'll go for introducing GLFW and GLEW. But yeah, so that's like kind of compiling with yeah, the command line. So now let's introduce using CMake. So yeah, I'm just going to create this. So once again, I don't want to scare you guys with how complicated this is. All we're doing really is including two external libraries. And the reason why we need both systems in C++ is because of how complicated it can kind of be to build using the command line. So you can see we have like 4 other random external libraries along with the 2 libraries that we were trying to include in the first place, right? So yeah, let's introduce building with CMake. So I'm just going to go back to the slide structure real quick. So to build with CMake, this is kind of what it looks like. So we're going to create a CMake file, and we're going to run CMake on this CMake file, and it's going to output a make file. So all CMake really is a system for us to create make files, if you guys are familiar with that. And the make file is actually what we're going to run to build our executable. So the make files is the one that's actually creating our executable, and CMake is the one that's responsible for generating this make file. So just a disclaimer, I'm not like an expert in creating make files myself, but yeah, of course, like I know that can get really complicated as well, which is why CMake was created in the first place, to kind of yeah, standardize, like, or not standardize, but create a more abstractified version of generating make files. So yeah, and CMake is cross-platform, which is another huge reason why we are using CMake. So yeah, let's go ahead to the demo again. And to do this, we have CMake list.txt. So CMake list.txt is the name of like any CMake file. And yeah, so if I'm actually going to introduce it a little bit later, you can have multiple CMake files and kind of link them together, quote unquote. So yeah, we'll kind of show that later. But for now, yeah, let's start our CMake file. So I'm just going to comment out like our like compilation message for commanding or compiling on the command line, and we're going to kind of compare that with what CMake looks like. So for CMake, we want to kind of specify like a minimum version, because there are older versions of CMake, and I don't think we'll be using anything particularly modern, but yeah, just a good thing to have for general projects, of course, when you're creating projects. And you can also have the option to specify a C++ standard. So yeah, for our purposes, of course, we're not really using any like modern C++, but you can specify what C++ standard you want to use. So I'm just kind of like going over this because I think it's nice to have, and you generally will probably want to have it in any project you want to make. So next we're going to introduce like kind of, since we want to output into the bin directory, we can actually specify that with this command, CMake source. So this is just an environment variable which contains like the source directory that we're in. So we're specifying the bin some directory within our project source directory. So of course, quite verbose. And yeah, so let's kind of discuss how we can include like, remember with our compilation, we had -i include as like a spot to look for header files. So in CMake, what that kind of looks like is we want to have target include directories. So yeah, if you're familiar with any like old CMake, you can also just do include directories, but that's like kind of old CMake, and we're introducing kind of newer CMake. So we want to specify that this is a headers and it's an interface and CMake current source. So of course, this is always relative to our project source directory, and bin or include. So this is the subdirectory we're looking for. And what's actually happening right here is with the name target, we're actually building we're actually kind of targeting a headers library. So we need to include like a library for this, library headers, which is just an interface. So I probably should have gone over that first, but we want to add this headers as like a potential library for us to build against. And we're specifying what include directories to look within. And this is kind of the bread and butter of using CMake, which is we want to add an executable. So this is where we kind of specify, remember we were specifying -o bin demo.exe. Here, this is what we're doing with CMake. So let's like call it demo CMake, and this is like what we're building onto. And remember before we specified which C++ files we want to build with. And here's the same exact thing. So demo.c++, and oh, I can't believe, oh my God, it keeps having that. So demo.c++, and we also want to use my class.c++. So I just like to separate onto different lines. Yeah, and there we go. And yeah, so now what about all this kind of stuff in between? Right, so we also have to specify that within CMake. So to link against those libraries, we're actually going to do target link libraries. Yeah, so and of course we're going to specify the target that we're building to, which is demo CMake. And now we're building or we're going to specify whatever we're building against. So headers is of course oh my God, headers is what we're first going to link against. And yeah, now we can just specify all of our like kind of previous things that we have here. So we can actually just like copy paste this list, I believe. Yeah, so we can just copy paste this list. So yeah, we can build against static libraries, or we can link it. So more properly, we can say we can link against like these library files. And we're going to remove the -l flag. So we're going to specify GDI, OpenGL32, kernel32, and user32. So yeah, this is what it looks like in CMake. And actually, I kind of forgot. Yeah, kind of forgot here. We need to. I'm not sure if we can make this a relative path. Actually, let's try. Actually, okay. The way I'm familiar with is we actually want to make this like an absolute path with project source directory, right? So we're just providing the path, however you want to do that. So cool. So this is what the CMake file should look like, and hopefully this runs. To actually run the CMake file, what we're going to do is CMake, and we're going to specify the source is right here, and we're going to specify the build directory, right? So this is kind of what I was talking about with needing build directory. Yeah, and then we're going to, so for me, I'm using MinGW, which means I have to specify a generator for a makefile. Yeah, I think like if you're using like a normal make system on Linux, you don't need this, but Yeah, here we're using MinGW make files as like our generator, and I'm just running the CMake command. So yeah, you see build files have been written to our build folder. So this is why we need a build folder. We don't want to clutter our root directory with all this kind of junk. And we're going to enter this build subdirectory. So here we have like the generated make file by CMake. So it's CMake generated, and we're going to run this make file to build. So make or MinGW-32 make is how I make with this. And oh, undefined reference to glue init. That's somewhat concerning. All right, guys. So actually, it was the same exact error as before. So remember, I took a bit to debug, and I found that I needed to include this definition right here of glue static, since we're linking against a static library for glue. Yeah. So to do that in CMake, actually, we need to just add a definition, and we need to add the glue static definition. And I believe this should compile now. And if you're following along, I actually had a typo up here. So yeah, just make sure to correct this. I was just like, this variable was just not named properly. So now let's try to run CMake. And yeah, let's run CMake, and we get MinGW-32 make. Cool. And we've okay, so actually I already built this before to test. But yeah, we build demo CMake.exe into the bin, and let's like try to run that. Demo CMake. Oh, I can't find it because now I'm in the build folder, and you guys can see that we actually have successfully built this program with this window, this white window. So yeah, that's kind of what it looks like to build using CMake. So yeah, I think this is just much more verbose how you can lay it out with separate commands. So yeah, just like to kind of run over it again, we can specify some CMake params. You can also like specify like a project name. We can set like the output. We can add where to look for our includes, and we can add our executable like C++ source files that we're going to be creating our executable with, which is kind of corresponds to these parameters right here. And then we can add flags based off of whatever flags we need. And then of course you have to, you can link with target link libraries against all these separate libraries. So yeah, I guess like that's like kind of what it looks like right here to kind of break down a G++ compilation command into a CMake file. Yeah, so now we're actually going to introduce like why CMake is so widely used, and with this GLFW source folder. So the GLFW source folder actually contains a CMake list, and we can actually utilize the CMake list to kind of like chain building CMakes. So yeah, let's like kind of just illustrate what that looks like. So we can actually add a subdirectory to build with, so I'm just going to do this all up here. So we want to add subdirectory. So add subdirectory is just going to look in the subdirectory you specify and run the CMake file in that subdirectory. So for us, we want to run the CMake file within GLFW 3-4. So W3-4, 3.4. So this is useful, or the slash. So this is useful if, for example, they do not provide like static libraries files for you to link against, and you actually need to build the source yourself, right? So if you want to build the source yourself, you can kind of figure out whatever compilation command they wanted to use to kind of build a library, like using like just your command line, or you could kind of just add it as a dependency within your CMake lists. So yeah, and they have some like kind of environment variables to specify that you don't want to build like docs, tests, and examples because we're only interested in utilizing it. And now actually, instead of kind of linking against this ugly looking like static lib a static library file, we can actually just link against the name of this project. So yeah, let's go ahead and give that a try. So Yeah, so we're generating the CMake file, and you can see it takes a little bit longer because it's actually looking within the CMake file for like the source. And let's try to run MinGW-make. So you can see it's actually building the source of GLFW. So yeah, if for any reason they don't have a MinGW distribution that matches like your setup, like for me personally, or like whatever setup you're using, you can actually build it yourself using CMake, right? And you don't have to do any extra work. They should provide the CMake file for you, and all you have to do is add subdirectory. So this is kind of like why I think CMake is pretty powerful. So yeah, we've actually built demo.cmake, and you can see that we have demo then demo CMake. You can see, and yeah, here we go. Here's a window that it generates. So hopefully this video helped you understand why we kind of want to use CMake as a build system. So yeah, just to kind of summarize, CMake is a cross-platform build system that can be used to generate make files to build C++ projects. Yeah, hopefully this video helped you understand the compilation process of C++ programs, specifically like from the command line. I know before, like I was kind of just handed make files or CMake files to just build my program with, and I never really got exposure to building using like the command line, like specifying include paths, specifying like all the files that you'll be using, and of course the libraries that you'll be linking against. So yeah, and how we can kind of convert that all into a readable CMake file, and the power of being able to chain CMake files with each other to build external projects and tie that into your own project. So yeah, thanks for watching, and I hope you learned something from this video.